Section 4.3 is using congruent triangles. This section is all about doing proofs. I have one set up where the given information is segment AB and CD bisect each other at point M. What we're trying to prove is that AD is parallel to BC. Have the illustration drawn to the right over here, and one thing I like to do is actually put down what we're trying to prove, and I'll put a question mark there, meaning it's not true, it's what we're trying to prove. So I'm trying to prove that this is parallel to this. We go back to our previous chapter. How do you prove lines parallel? You prove lines parallel by proving corresponding angles congruent. So we want corresponding angles to be congruent, alternating interior angles being congruent, or same side interior angles being supplementary. So I told you back in chapter 3 that these were the main three concepts going forward for parallel lines that you needed to know. So in this case here, we're looking to see if we can actually come up with one of those three. So what we have here is that M is the midpoint. So we're going to put down what we do know. I'm going to put what we do know in blue, and in red is what we're after. So AB and BC bisect each other at point M, which means M is the midpoint of segment AB. And also M is the midpoint of segment CD. So that basically means this segment is congruent to this segment. These two segments are congruent. And based on that information, we have two sides here. It's either going to be side, 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 or it could be side, angle, side. And once you look at it, you realize that this angle here and this angle here are vertical angles, which makes them congruent. So are these triangles congruent? Answer is yes. So in order to prove, and this is working the proofs backwards, which is a good way of working them sometimes. Start with what you're trying to prove and work them backwards. In order to prove that segment AD and segment BC are parallel, if I can prove that angle A is congruent to angle B, then alternating interior angles congruent makes lines parallel. How do you prove angles congruent? If I could prove triangle ADM is congruent to triangle BCM, so if I could prove triangles congruent right here, then CPCTC says that corresponding parts are congruent, and if that's true, then this has to be true, because when alternating interior angles are congruent, that implies parallel lines. So basically what we do, and this is the first time we've seen this method, is we're working the proof backwards. We're actually starting what we need to prove right here and going to work it down until we get to the place where we can actually prove. We've talked a lot about, back in section 4.2 rather, how to show triangles are congruent. Now we're actually going to use it in a proof. Okay? So based on this information, based on what we know the triangles are congruent because of side, angle, side. We also know that this is going to be true because of CPCTC, and that's true because of this. So we actually have our statements and reasons for the last three steps, but we now have to put what we need in the actual proof. So step number one is our given. I won't recopy that. I'll pretend like I did to save a little time. So that's given information. No, you guys can't do that. You need to write it out. Remember, I'm a professional. I get away with things like this. Step number two. Now what's it mean to be a bisector? The bisector says it passes through the midpoint. So we're establishing the fact that M is the midpoint here. Okay? So M is the midpoint of both segment AB and segment CD. And that's going to be your definition of a segment bisector. Step number three, since M is the midpoint, that means that the distance from A to M is equal to the distance from M to B. Actually, we're going to put congruency here. Okay. Segment AM is congruent to segment MB, and also for the same reason means that DM is congruent to MC. And that's your definition of midpoint. Okay. So at this point here, the question is, do we have enough information for congruent triangles? What we have is we have a side here, we have a side here, but what is missing is the angle. So we need to insert our angle here, which is the angle 1 is congruent to angle 2, and that's because of vertical angles. And I put step 3 there, or 2, that should be 3. And step number 4 here is going to be a vertical angle theorem, or just vertical angles are congruent would be sufficient. Are we ready for congruent triangles? Answer is yes. Now notice I didn't really put it in the order of side angle side, which is all right. You don't really have to do it unless you want to. I just need to make sure that those 3 pieces of information are in there to be able to prove triangles are congruent. So step number 5 is going to be triangle ADM is congruent to triangle BCM. And the reason for that is going to be side angle side. And immediately after congruent triangles, almost 100% of the time, you're going to use CPCTC. Because remember, there are 6 parts of correspondence for this triangle here being congruent, and of those 6, we've only used 3 of them, which means there's going to be 3 left. Okay, and it's at this point here we're actually going to use one of those other 3, and the part of the other 3 is going to be angle B, or I'm sorry, angle A rather, is congruent to angle B. Okay. Now we don't have to do a whole lot of thinking here because we've already done the groundwork up here prior to actually starting the proof. We realized we wanted A and B being congruent here and here, and then that led into the parallel lines. Step number 6 is going to be CPCTC. Immediately following congruent triangles 100% of the time, or practically 100% of the time, is CPCTC. And then because angles A and B are congruent, that means that AD is parallel to BC. And the reason for that is going to be when alternating interior angles are congruent, that implies parallel lines. Alright, so here's some general knowledge here for proofs. If you're trying to prove, say, congruent angles, congruent segments, parallel lines, perhaps midpoint, and a few others, but this is a general list right here. If you're trying to prove any of this, what you're going to look to do is prove congruent triangles and then use CPCTC. Okay? Because if we can prove triangles congruent, then corresponding parts, which is works really well for congruent angles and congruent segments, because that's all part of those triangles. So keep that in mind when you're doing your proofs, that if it says prove segments congruent or angles, you typically are going to look to prove triangles congruent, then use CPCTC. I'm going to do one more proof for you, but before I do that, I want to introduce a definition, and this definition is the definition of a line perpendicular to a plane. And it's kind of a common sense thing, but I'll draw it out. So here's plane M. If I have a line perpendicular to the plane M, let's call that line L, that means it's going to form an angle right where it intersects the, and that's not a very good line, but we'll live with it, right as it passes through plane M. Okay, so in this case here, L is perpendicular to plane M, and what this definition says that the line is also perpendicular to any line in plane M through that point. So if I were to draw a line through here and call it, let's say, line T, L has to be perpendicular to T as long as T is on plane M, and it also passes through that point. If I put another line in here, let's call it line Q. Okay? As long as line Q is in plane M and line Q passes through that point of intersection of L, then it also must be perpendicular. Okay? So if a line is perpendicular to a plane, it's perpendicular to all lines in the plane at the point of intersection. So I'll read it to you. If a line is perpendicular to a plane, M, oh, this is not part of it, I'm sorry. That was already written over here. So if a line is perpendicular to a plane, then it is perpendicular to all lines in the plane at the point of intersection. That's a lot of information there. If you're going to use this in a proof and it comes up occasionally, I would just put down the definition of a line perpendicular to a plane, and you don't have to write it out. If you do that, I'll understand and know what you mean. So this next proof I already have set up for you to spare the extra time put in to write it out. So given PO perpendicular to plane X and AO is congruent to BO, there's the illustration accompanying it. We want to prove that PA is congruent to PB. Now in the previous problem I said in order to prove segments congruent, we really want to do what? Prove triangles congruent. So we're going to look for a set of triangles and figure out which triangles we're going to use and prove them congruent. Okay? And we're going to figure out why we're going to do it. So the first thing I would do is take a look at the given and put it on the illustration. Okay? Two ways to start a proof. One is take your given information, put it on the illustration, and sometimes you take what you want to prove, work it backwards, and then go and put the information on. So if we were to take a look at it, let's say we want to work it backwards here. Here's PA right here, and here's PB, this one. In order to prove those segments congruent, if I could prove triangle PAO was congruent to triangle PBO. Oops. If I can prove those triangles congruent, then would it be true that those segments are congruent? Yeah. So we just want to figure out why those triangles are congruent, and we know it's one of three reasons. It's either going to be side, 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 angle, side, or angle, side, angle for now, because we only have three. And once we prove triangles congruent, we know this is going to be true because of CPCTC. Okay, so that's kind of the mentality of going into the proofs. Now we just want to take our given information up here and apply it and see what information is going to allow us to prove triangles congruent. So PO is perpendicular to plane X, and we know a line perpendicular to a plane will be perpendicular to all lines in the plane through that point of intersection. So we can actually prove that this is perpendicular here and here. Okay, I'm actually going to go back through and I'm going to put in blue so we can see what we need. Okay. All right, so the blue is what we're after here. We don't really have this in a proof. We're going to put it in there. So I can prove that this is perpendicular here, this is perpendicular here. Okay. We also have the reflexive property here if we need it, and also given is the fact that AO is congruent to BO. So that's already given up here in the proof, so we won't have to come up with it. Okay. So are the triangles congruent? Yes, they are. Why? Because we have side, angle, side. So we know the reason. Now we just got to get the information in. Number one, again, I won't copy it down. It's basically all this information, given information. I will put down that AO is congruent to BO. But remember, you'll want to copy it all down. Step number two, so that's given. Step number two, we can do the reflexive property right away, which is going to be PO is congruent to PO. And that's going to be the reflexive property. Step number three, can we go right into these angles here being congruent? The answer is no. all it says is it's perpendicular. So we're going to have to jump through hoops. Based on our definition we just talked about, it says they're perpendicular, but it doesn't say that they're actually congruent. Okay, so you're going to read between the lines and try to make things up. Okay, so the best we can do is say that PO is perpendicular to AO, and for the same reason PO is perpendicular to BO. And what's the reason for that? That's the definition of a line perpendicular to a plane. It says it's perpendicular to all lines in the plane at the point of intersection. What's it mean to be perpendicular? Now, for convenience, I'm going to actually number these angles right here. So I'm going to number this angle 1 and this one 2 over here. Okay. So based on that information, step number 4, it says that they're perpendicular. That really means that angle 1 is a right angle, and angle 2 is also a right angle. So both those angles are right angles. Why? That's the definition of perpendicular from back in chapter 2. Perpendicular implies right. Okay. Now that we know they're right angles, step number 5 means that the measure of angle 1 is 90 degrees, and also the measure of angle 2 is 90 degrees. Why? That's your definition of a right angle. It says that they're 90 degrees. Since these are both 90 degrees, couldn't we substitute in measure angle 1 for 90 over here, and now it says the measure of angle 1 is equal to the measure of angle 2. Okay, so we're getting close, and that's the substitution property. Are we ready? Answer is not quite yet, because remember, side angle side says that two sides and the equivalent angle are congruent. This says equality, which means it's necessary to change that equality to congruency. So what we end up with here is that angle 1 is congruent to angle 2. That's the definition of congruency. It says if they're congruent, they're equal, or if they're equal, they're congruent. Now are we ready? Do we have enough information? We said it's side angle side. I have a side here, I have a side here, and I have the angle that we're going to be using, that sandwich in between the two sides. So we're actually ready for congruent triangles. So it's nothing more than copying down where we were at right back up here. So triangle PAO is congruent to triangle PBO. That is because of side angle side. Step number 9 is going to be that PA is congruent to PB. And the reason for that is CP, CT, C. Alright, so that's how we do that proof there, 9-step. That's a pretty good proof. There are proofs that'll have steps, right around 8, 9, 10, so this is one of the more difficult ones. If I were to go back up here and say, you know what, I don't want to prove this right here. What I'm really after is I really want to prove that angle A is congruent to angle B. Okay. Do I need to erase this proof and start all over, or can I just adjust what we have there? Well, if you're thinking we need to start all over, then you kind of miss the whole point of what we're talking here. If you're saying, you know what, we don't need to do anything but just readjust what we've done here, then you're on the right track. Because remember, in order to prove angles congruent, you're going to prove triangles congruent, which we already did. So really all we need to do is just take this last step right here and change this out to angle A is congruent to angle B because of CP-CTC. Two nice proofs there. Hopefully you're on the right track. There's a lot of good proofs coming up yet. That's the end of section 4.3. Good luck on your homework.